Hello, welcome to lesson 8 of Erlang tutorial. In this lesson we'll be discussing recursion and I will show the examples of recursion, Fibonacci, calculating and Fibonacci number, calculating factorial of number and calculating average of some list of values. So recursion is basically the ability of function to call itself, and there is so function calls itself to execute some calculations. And there is also tail recursion, which is very popular in functional programming languages. Basically, if the call to itself happens at the end of the function, then it's called the tail recursion. And functional language like Erlang will optimize this code, and it will use it as a loop. I will show it in the future how to implement loops and other control abstracts but for this also, yeah, this information what the recursion is very useful. So let's start with the examples. I will start with the Fibonacci numbers. So let me define the new Erlang module. I will call it Fibo, and okay, I define it's Fibo, and it will export only one function, Fibonacci. The name of the function is Fibonacci. The arity of the function is 1, which, if you remember from the previous lesson, means that the function takes only one argument, the Fibonacci number, which should be calculated. And now the recursive definition will contain three clauses. This function Fibonacci will contain three clauses. It's possible to write it with only two clauses, but for this you need to know the concept of guards in Erlang, which I will introduce in the future, and I will show how to rework this function so that it will have only two clauses. So first, if you remember, basically the Fibonacci number is the sum of two previous Fibonacci numbers. So this is the recursive definition. To calculate the nth Fibonacci number, you need to take the if you have the nth Fibonacci number, you need to sum n minus 1 plus of n minus 2. So basically this is it. Now it's not full definition, because also we need to say, okay, what happens for, because this we could go to, yeah, to negative numbers. So the definition is that for 0 we want to return 0. This is the clause, first clause. And for 1 we want to return 1. So how it will work, when we will pass, for example, a couple of examples. If we will pass Fibonacci 0, then the result is of course 0. If we will pass 1, the result is also 1. This is from these two first clauses, right? Now, if we will pass the value greater than 1, for example 2, you see that it's not defined in these first two clauses, so it will go to this third clause, and it will do the calculation like this: Fibonacci of 1 plus Fibonacci of 0, and this equals to 1. Another number 3, we have Fibonacci of course 2 plus Fibonacci 1 equals to, we know that Fibonacci of 2 is equal to 1 because we calculated in the previous step here. So it's 1 plus Fibonacci of 1 equals to 1, so 1 plus 1 equals to 2. And you see that the next number would be 3, and then 5, and then 8, and so on. Now, this is not optimal implementation of this algorithm. Of course, this is quite nice to demonstrate recursive algorithms, but the algorithm itself is not the best, because as you can see, if you would calculate the third Fibonacci number, you would again calculate number 0, 1, and 2, and you would do it for each number. So this is not very efficient implementation, but it's good to implement to demonstrate recursion. So let me maybe run this in Erlang shell. I will save it and I will open Erlang shell. So first, if you remember, I need to compile my module. Okay, there are no errors. Everything is successful, and now I can call it like this. I need to refer to Fibo module and the Fibonacci function, and I can start with, okay, Fibonacci of 0 is 0, Fibonacci of 1 is 1, Fibonacci of 2 is again 1, Fibonacci of 3 is 2, Fibonacci of 4 is 3, 5, and so on. So you can see here this how it works. Let me close it and go back to implementation to once more have a look. Yeah, as I demonstrated here, it will work like this. So the next algorithm, which will demonstrate quite nicely recursion, is factorial. So the factorial, I will show the definition also. I will create a new module, and we have factorial. Module name is factorial, and it will export one function with arity1, which will calculate the factorial of the number. And now, a similar situation to Fibonacci, but here the factorial, if of course, if we have, for example, 3, factorial of 3, it will be 3 times 2 times 1 equals 6, right? And similarly, a factorial of 4 would be 4 times 3 times 2 times 1, and so on. So this is the definition. It's always the factorial of 4 is equal to this multiplication. So in the definition, factorial of 0 is 1, factorial of 1 is also 1, and similar story here. We could use the guard, but since I haven't introduced this concept, I will use free clauses to implement this function. And if I have factorial of 1, I want to calculate n times factorial of n minus 1. So you again see that the function calls itself, like in the Fibonacci case. And again, we could have a look. Okay, if we have example with 0, it will go to this clause because we have the pattern matching 0, so it will be equal to 1. If you have the 1, again, we go to second clause and we match it and return 1. Next, if we have, for example, 2, we go to the last clause here and we do something like 2, because we have the n of here will be 2, so we have 2 here, and the factorial of n minus 1, which will be times 1. So here we have of 1, we know that this factorial of 1 is 1. So we can actually replace it and write something like this, equals to 2. Factorial of 3 is of course 3 times factorial of 2. And we know that the factorial of 2 is here and it's equal to 2. So we can just type 2. It will, let's say, expand this expression to exactly this thing. 2 times 1. And yeah, we have 6. So this is how this pattern matching and recursion will work here. By the way, I haven't mentioned this in this tutorial, but in Erlang there is no such thing as return statement like in many imperative languages. Always the last value in the function is the value which will be returned from the function. Like here 1, 1, and this expression, result of this expression here. So let me save it and then let me compile it in the Erlang shell. We will clear my screen. To compile, C factorial. I have factorial with no, let's say, problems, no errors, so I can try to invoke it. For 0, it will be 1. For 1, also 1. For 2, 2. 2 times 1. For 3, 6. For 4, 24. 5, 120. 6, 720. 7, and so on. So this is again another example of recursion. And in Erlang, you are using recursion to implement many algorithms, also like loops. There are no such things as loop or other control abstractions. It's implemented as this recursive function with tail recursion. I will show it in the future, but for this, yeah, this recursion is important to know, to get this, let's say, knowledge. And the last thing is I would like to implement module to show how to use recursion to process the lists. In this case, I will implement the average module. I will call it like this. So I will type module avj and then export. I want to export just one function like this with ret1 and average of the list. So this will be the list. Some list will be the argument of this function, will be calculated like this. It will be sum of all elements in this list divided by length of this list. Of course, this is well known, right? Average is the sum of the elements divided by the number of elements. Simple average. So here we have like this. Length is beef. So the so-called beefs are the built-in functions. This is the short for built-in function. So the length, I didn't have to import it. It's built-in. It's imported by default. So what I can do, sum is not built-in. Sum I need to define in this case. I mean, there is some sum. You can import it from standard library, Erlang standard library, but for my purpose, I will implement it to show you how to implement recursion, how to process lists. Now, I want to first to do the clause for empty list. So it was the sum of empty list is 0, right? Because there are no elements, so I want to return 0 for such sum. Now, the input for this for my average function, let's say I want to calculate, I have some students, John, Adam and George, for example, and each of them got some score. For example, he got 4, he got 6, and he got 1, for example. And here, or this could be the score of in some game or anything. And I want to calculate, I want to this function, I want to pass list, which will look like this. It will be list of tuples, and each tuple will have the name of the student or the player or whatever. For now, we can say these are students. And then I want to do it for each of these guys. I'm passing more complex data structure here to demonstrate how to do this, how to use this recursive nature of the list in Erlang, and how to do this pattern matching on such thing. So in this case, as I remember, as I mentioned, for empty list, we want to pass something like this, 0. It will be 0. For for non-empty list, we want to use something like this: student score. This will be the tuple which contains a student name and a score. In this example, we want to use student name, but we can use it for matching. I mean, we won't use it inside the function. And then we can type inside this function score times sum of t. So so you can see that here we want to, at first, in the first call of this function, we will get complete list. And then in this call, we will call for times sum of this list. Because we said that we want to have this head. So here we will have a head, and here we will have, so the first element of the list, and here we'll have the tail, which is the other element of the list, remaining elements. So then in this call means basically that we will have 4 times this score, 6 times sum of this list. So next we will get sorry, it's of course not multiplication, but the sum. So I need to give the plus sign. So everywhere I need to, because we're calculating the sum, not the multiplication. And here we'll get 4, 6 plus 1 plus sum. The tail will be empty, so it will return the so we will go to this clause of this function, so we will return 0. So the last call will be 4 plus 6 plus 1 plus 0, which of course doesn't change the result. And once we have this calculation, it will be of course 11, and we will divide it by 3 because we have 3 elements in this list, and we'll get the result. So this is it. Let's call it from Erlang shell. Erlang C. I got the warning that the student is not used. Of course, in this example, this is quite artificial example. Therefore, I just put this student to process more complex data structures, like in this case tuple. But you can imagine that in some more advanced example, I could have here a student would be used for some kind of calculations, or for logging, or for anything else. Okay, once I compile this module, I can invoke my function. Okay, so let's define first list of students. We have John. We have, for example, Adam, who got 6, and we got George, I like in this original example. And we have this list of tuples, and let's calculate the average of these scores. I want to know what was the overall average of this score. So I'm typing like this, and here I'm passing students list, and I got the result here. So I think this is it about the recursion. Of course, in the function, in the future, I will show some other examples how to use recursion, how to define your control abstraction. And but for this concept, I will need to introduce fans, which I will do in the next video. So stay tuned and have fun with recursion. Cheers.